Raymond Cook stared at a jungle of speaker parts in a Kent workshop. In 1961, the BBC demanded precision so strict that most manufacturers just guessed. Cook vowed to replace guesswork with science. From this single promise, KEF's obsession with measurement was born, reshaping how the world hears music. But what pushed a small English factory to set new global hi-fi standards? And why do their strict tolerances still matter today? The answer begins where myth meets measurement. Raymond Cook worked late into the night, surrounded by soldering fumes and the clatter of metal in a Kent Nissen hut. In October 1961, he registered KEF Electronics Limited, naming it after the Kent engineering and foundry next door. The company's first home was a cluster of wartime huts beside the River Medway, a far cry from the polished factories of big audio brands. Cook, a former BBC engineer and a 5-year veteran of Wharfdale, had seen the limits of tradition up close. He had watched as loudspeaker makers relied on craft and instinct, letting the quirks of paper cones and human judgment shape every product. That was not good enough for Cook. He wanted every loudspeaker to sound the same, every time, for every listener. His answer was blunt. He said he was obsessed with reproducing sound as naturally and unobtrusively as possible. Cook's approach was not just about tools or materials. It was a way of thinking, one that put measurement and repeatability above artistry and luck. He insisted on testing, retesting, and documenting every step, even when others said it was too slow or too expensive. The earliest KEF loudspeakers, like the K1, used synthetic diaphragms instead of paper, not because it was easy, but because it meant consistent performance in any climate. Cook's exacting standards shaped the company's culture from day one. Quality, honesty, dedication, and innovation became the unwritten rules in that chilly Kent workshop. What began as one engineer's stubborn refusal to guess would soon ripple out, changing the expectations of an entire industry. Precision was not just a matter of pride for KEF, it was a necessity for their most demanding client. The BBC, responsible for broadcasting across the United Kingdom, needed studio monitors that would sound identical in every control room. For engineers, even the smallest difference between speakers could mean a missed cue or a muddied broadcast. Technical specifications left no room for error. Frequency responses had to fall within strict tolerances, and every unit had to match its pair within a fraction of a decibel. At the heart of this partnership stood the LS35A, a compact monitor developed by BBC engineers in the early 1970s to deliver accurate sound in small spaces like mobile vans and editing suites. The BBC Research Lab designed the LS35A, but it was KEF that supplied the critical drivers, the B110 mid-bass and the T27 tweeter, chosen for their repeatable performance. When the BBC issued production licenses to a handful of manufacturers, KEF was the source for the key components, ensuring that every LS35A, whether built by Rogers, Spender, or Harbeth, would meet the same acoustic standard. To satisfy BBC demands, KEF imposed quality control processes that were rare in the industry. Each driver batch underwent exhaustive testing, and any unit that did not measure up was rejected or replaced. This approach allowed KEF to guarantee that a speaker in London would sound the same as one in Glasgow or Cardiff. The LS35A soon became a legend, not just for its size, but for its promise, perfect consistency, every time, everywhere. In meeting the BBC challenge, KEF transformed the very idea of what a loudspeaker company could achieve. Inside KEF's Kent workshops, the pursuit of sonic consistency moved from theory to practice. Engineers swapped out traditional paper cones for Bextrine, a synthetic material developed to resist the warping and color shifts caused by humidity and age. This was not just about durability. Bextrine's uniformity allowed every driver to perform with near-identical precision, batch after batch. Factory workers logged measurements for each component, building a database of matched pairs. Each one was checked to ensure frequency responses stayed within a razor-thin margin, often just plus or minus half a decibel. That level of control was almost unheard of in the 1960s, when most manufacturers accepted much wider tolerances and left matching to chance. The process began before assembly, with raw materials tested for density and elasticity. Each B110 mid-bass and T27 tweeter destined for a BBC monitor was measured, sorted, and paired by hand. If a unit drifted outside the specified range, it was rejected, no matter the cost. The result was a speaker that could be trusted in any broadcast environment, whether in a London studio or a mobile van parked in the Scottish Highlands. This rigorous approach became embedded in KEF's culture, shaping not just the LS35A but every model that followed. By the end of the 1970s, KEF's reputation for matched pair accuracy and synthetic cone reliability had set a new benchmark. The company's engineers, armed with data and driven by accountability, laid the groundwork for the next leap, using computers to model and predict performance before a single part left the factory floor. In the early 1980s, the sound of progress at KEF was no longer just the whir of lathes or the tap of a soldering iron. Instead, it was the hum of computer fans and the clatter of keyboards as design engineers gathered around new computer-aided design workstations. In 1973, KEF became the first loudspeaker manufacturer to introduce computer-aided design into its engineering process. These early computers, often the size of a small desk, allowed the team to plot cabinet dimensions and simulate acoustic behavior before a single piece of wood was cut. For the first time, engineers could predict how a speaker would sound using mathematical models, not just prototypes and listening tests. By 1981, KEF had adopted finite element analysis, known as FEA, bringing a new level of detail to their work. With FEA, engineers could map how vibrations would travel through a speaker cabinet, pinpointing weak spots and resonance issues that would have taken months to find through trial and error. The reference 1042, launched in the early 1980s, benefited directly from these simulations. Waterfall plots and modal maps revealed how sound waves moved inside the enclosure, guiding subtle changes in bracing and damping that resulted in a cleaner, more accurate output. Cabinets were no longer designed by intuition. Every curve and brace was justified by data. This digital approach did not just speed up development. It changed the entire philosophy of loudspeaker design at KEF. Engineers could now test dozens of ideas virtually, ruling out flawed concepts before any physical parts were made. They could optimize crossovers, predict how components would interact, and ensure that every speaker would perform as intended, not just in the lab, but in real living rooms. The transition from hands-on guesswork to simulation-based design laid the foundation for future breakthroughs. When the time came to tackle more complex ideas like coaxial drivers and advanced dispersion control, KEF's engineers were ready, armed with a digital toolbox that gave them a clear view into the heart of every speaker they built. By the late 1980s, KEF's engineers faced a challenge that had frustrated loudspeaker designers for decades: how to make sound radiate from a single point so every listener, no matter where they sat, would hear a perfectly focused musical image. The answer arrived in 1988, after years of experiments, heated debates, and late-night sketches in the Maidstone lab. That year, KEF patented the Uni-Q driver, a coaxial design where the tweeter sits at the exact acoustic center of the mid-range cone. Instead of stacking drivers above and below each other, Uni-Q aligns them on the same axis so their sound waves launch together, as if from a single source. The principle sounds simple. In practice, it demanded new materials, custom magnets, and months of computer modeling. Early prototypes used compact neodymium magnets to keep the tweeter small enough to fit inside the mid-range without blocking airflow or causing distortion. Engineers like Laurie Fincham and Mike Goff recall the first time they saw the impulse response, a single, clean wave expanding outward, free from the ripples and timing errors that plagued conventional designs. Lab data confirmed what the team heard. Polar plots, circular graphs that show how sound spreads at different angles, revealed a breakthrough. Where traditional speakers showed dips and peaks as you moved off axis, Uni-Q's response stayed smooth and even, from the center seat to the far edge of the room. Impulse measurements showed the tweeter and mid-range working in perfect sync, eliminating the comb filtering and phase problems that blur stereo images. For the first time, listeners were not chained to a narrow sweet spot. KEF engineers demonstrated the difference in controlled listening sessions. With a conventional speaker, a voice or instrument seemed to drift as you moved around. With Uni-Q, the image stayed locked in place, even at sharp angles. On-screen measurements, frequency sweeps, directivity plots, and real-time spectrum displays provided undeniable proof. The Uni-Q driver did not just sound different, it measured different in ways that matched what listeners actually experienced. This invention became the heart of nearly every KEF speaker from that point on, defining the company's identity and setting a new standard for how high-fidelity sound could fill a room. In 1992, KEF's future took a new direction. The company was acquired by Gold Peak Group. a Hong Kong-based industrial conglomerate known for investing in technology brands. The deal brought fresh capital and a broader reach, but it also raised questions about what would happen to KEF's engineering-driven culture. Some feared that moving manufacturing overseas might dilute the brand's identity, or that decisions would now be made far from Maidstone. But the new owners made a deliberate choice. Research and development would remain anchored in the UK. The Maidstone facility, where so many breakthroughs had started, continued to house KEF's core engineering team. New labs were built, and the company invested in advanced measurement systems and computer modeling tools, ensuring that the technical heart of KEF stayed where it had always been. With GP Acoustics overseeing operations, KEF began to manufacture products in several locations, including China and Malaysia. This allowed the company to scale up production, serve new markets, and weather the economic pressures that challenged many traditional hi-fi makers in the 1990s. The ability to source components globally and build at higher volumes gave KEF the resources to pursue ambitious projects that smaller firms could not match. Yet, every new model still traced its lineage back to the Maidstone lab, where prototypes were measured, tweaked, and perfected by the same team that had pioneered Uni-Q. The result was a company that could compete worldwide without losing its roots in British engineering. Even as KEF speakers reached homes and studios across Europe, Asia, and the Americas, the sound and the science remained unmistakably tied to the place where it all began. Blade arrived in 2012 as the physical proof of KEF's engineering ambitions. Its slender cabinet, free from sharp edges, houses 4 side-mounted bass drivers arranged in perfect symmetry, each one firing in opposition to its twin. This force-canceling setup means vibrations are absorbed within the structure itself, allowing the cabinet to disappear acoustically. Engineers spent years refining the details, using computer simulations to predict how every surface and joint would affect the sound. The result is a speaker that can fill a large room with deep, controlled bass, and a sense of scale usually reserved for much larger systems. The LS50, also launched in 2012 to celebrate KEF's 50th anniversary, took a different approach. It distilled decades of research into a compact bookshelf design, using the latest Uni-Q driver at its heart. The LS50's curved front baffle and rigid enclosure were shaped by hours of finite element analysis, minimizing unwanted resonances. In side-by-side listening tests, the LS50 delivers a stereo image that remains stable even as you move around the room, thanks to the coincident driver's even dispersion. Measurements back up what listeners hear: a smooth frequency response, low distortion, and a directivity pattern that is remarkably consistent from any seat. A decade later, the LS60 wireless built on this legacy, combining active amplification, digital signal processing, and advanced Uni-Q arrays in a slim tower. Introduced in 2022, it brought true high-fidelity sound into the wireless era, with each speaker driven by its own dedicated amplifiers and tuned for the room via onboard calibration. Reviewers praised the LS60 wireless's ability to recreate the scale of Blade in a more accessible package, while offering the convenience of streaming and app control. Across all 3 models, KEF's commitment to measurement and innovation is not just a philosophy, it is something you can hear, and for those who care about the numbers, something you can see in the data. Wireless audio once meant compromise, but KEF's engineers saw an opening for something more. In 2017, the LS50 wireless appeared, a compact system that delivered the clarity and imaging of a reference speaker, but with streaming, app control, and built-in amplification. Audiophiles took notice. Critics at What Hi-Fi and Stereophile praised the LS50 wireless for bringing true hi-fi into the digital age, describing its sound as precise, open, and surprisingly powerful for its size. The LSX followed in 2018, shrinking the concept further. This bookshelf model offered full stereo separation in a form factor that fit on any desk or shelf, with the same focus on soundstage and neutrality that defined KEF's legacy. Both the LS50 wireless and LSX made it possible to enjoy high-fidelity sound without racks of gear or tangled cables. The shift wasn't just about convenience. KEF's wireless lineup kept the company's measurement-first philosophy at the center. Each system used advanced digital signal processing to ensure that the frequency response and imaging stayed consistent, no matter the room or placement. The Uni-Q driver, now in its 12th generation, remained the heart of every model, providing even dispersion and a stable stereo image across a wide listening area. Reviewers noted that for the first time, listeners could get audiophile-grade performance from a speaker that looked as at home in a modern apartment as in a dedicated listening room. For perspective, audio historian Dr. Emily Carter points to KEF's unique position. Few companies have managed to bring studio-grade sound into everyday living spaces without diluting what makes it special. KEF's wireless models are not just convenient, they are a direct extension of the brand's engineering DNA. Today, KEF's wireless systems aren't just products, they are a statement that high-end audio can fit seamlessly into modern life, proving that the science of sound and the reality of daily living no longer have to be at odds. KEF's relentless focus on engineering still shapes how we experience music at home and beyond. As wireless and digital audio redefine listening, precision matters more than ever, affecting everything from streaming speakers to immersive home theaters. The science behind every note is not just history, it is the foundation for how the world hears tomorrow. What does sound mean to you today? Share your thoughts below.